impurities are introduced on one side and acceptors on the other side of a single crystal semiconductor, germanium, a p-n junction is formed as shown above. The donor ion is indicated by a plus sign because after this impurity atom donates an electron, it becomes a positive ion. The acceptor ion is indicated by a minus sign because after this atom accepts an electron, it becomes a negative ion. Initially, there are nominally only p-type carriers to the left of the junction and only n-type carriers to the right. Since there is a density gradient across the junction, holes will diffuse to the right across the junction and electrons to the left. As a result of the displacement of these charges, an electric field will appear across the junction. Equilibrium will be established when the field becomes large enough to restrain the process of diffusion. The general shape of the charge distribution is shown in figure B. The electric charges are confined to the region of the junction and consist of fixed ions. In the p-type, the positive holes which neutralize the acceptor ions near the junction in the p-type germanium have disappeared as a result of the combination with the electrons which have diffused across the junction. Likewise, the neutralizing electrons in the n-type germanium is combined with holes which have crossed the junction from the p material. The unneutralized ions near the junction are referred to as uncovered charges. Since the region of the junction is depleted of mobile charges, it is called the depletion region or the space charge region or the transition region. The electric field intensity near the junction is shown in figure C, which is the integral of the density function ρ. The electrostatic potential variation in the depletion region is shown in figure D, which is the negative integral of the electric field intensity epsilon of figure C. The variation constitutes a potential energy barrier against a further diffusion of holes across the barrier. The form of the potential energy barrier against the flow of electrons from the n side across the junction is shown in figure E. Figure E is inversion to figure D since the charge of an electron is negative.